Hello, I hope you're having a good day. Today we're going to learn something very different. We're going to learn how to translate English statements into our symbolic language of propositional logic. Yes, it's very different from what we've been doing. In this lecture, I'll introduce you to translations in propositional logic. I'll show you how to translate statements into propositional logic, and then I'll show you how to translate logical operators into propositional logic, and then we'll practice a bit. So, here's my intro. Here are the basic components of propositional logic: logical operators or connectives, and simple statements. So a logical operator or connective in English would be something like not, and, or, if then. These are phrases that you can use to combine or alter statements. So, Obama is president. You could take that statement and combine it with Obama is not president. You could combine it with the word or. Obama is president or Obama is not president. So what we did is we took two simple statements and we combined them using the word or. So you translate logical operators into symbolic logic, or our symbolic language of propositional logic. So not translates as tilde, and translates as dot, but we'll get into that. And then you have simple statements. This is the other basic component of propositional logic. An example is Hamlet is a tragedy. That's a simple statement in English. And it translates into propositional logic as H. Or it could be any capital English letter, B, D, Z, whatever. Hamlet is not a tragedy is not a simple statement because it includes the word not. Not, if you see above in this section on logical operators, not is a logical operator. When you combine not with or you alter Hamlet is a tragedy with the word not, the result is something that's not a simple statement. So now let's see how we can translate statements into our propositional language. A simple statement, first of all, is one that does not have another statement or logical operator as a component. So the statement, Obama is president or Obama is not president, that is not a simple statement because it has two statements squished together with the word or. Hamlet is a comedy, let's go with that. Hamlet is a comedy, that's a simple statement. It doesn't have a logical operator or another statement as a component. So, in propositional logic, we use English capital letters to represent simple statements, and we call these statement letters. So, any of A, B, C, D, all the way through Z, as long as they're capital letters, can be used to represent any simple statement in English. So, we can use the letter H, as long as it's capital, to represent Hamlet is a tragedy. We could use K to represent Kung Fu Panda is a comedy. We could use T to represent Kung Fu Panda is a tragedy. Or we could use P to represent Hamlet is a tragedy, or Z, or Y, as long as it's a capital letter in English. You can use it to translate an English statement into our propositional language. So, if we use logical operators in simple statements, we can form compound statements. Compound statements are statements that have a simple statement as a component, as well as a logical operator or other statements. So Hamlet is a tragedy and Kung Fu Panda is a comedy. That is a compound statement. It has Hamlet is a tragedy, Kung Fu Panda is a comedy, so two simple statements plus the word and. And so you know, as a heads up, the way you would translate that into propositional logic is H dot K. Or it could be P dot T, or it could be Z dot A. It is not the case that Kung Fu Panda is a tragedy. That's a compound statement as well. It has the simple statement Kung Fu Panda is a tragedy. Combined with the logical operator, it is not the case that. So that would be a compound statement. And we translate that into propositional logic using the tilde and then K. Okay, so look at these statements, each of these statements, and I want you to tell me which are these statements, simple or compound? Wednesday is hump day. Is that simple or compound? Joan is not coming, simple or compound, etc., etc. If you'd like, you can pause the lecture right now to try to figure it out, or you can just look at the answers when I display them right now. Okay, Wednesday is hump day, simple. There is no other logical operator or statement involved. Joan is not coming, compound. Not is a logical operator. Joan is coming is a simple statement. Combine those and you've got a compound statement, which is a simple statement plus a logical operator. If the IRS processed my return, then I should get my refund this week. There are three components to this one. The simple statement, the IRS processed my return. The simple statement, I should get my refund this week. And then the logical operator, if then. Note that if then acts as a single logical operator. The next one, either Kung Fu Panda is a comedy or it's a tragedy. You've got two logical operators and two simple statements. One logical operator and two simple statements. Kung Fu Panda is a comedy. That's a simple statement. Kung Fu Panda is a tragedy. That's a simple statement. Or either or, is a logical operator. Combine them and you got a compound statement. You will graduate if and only if you meet all university requirements. Again, if and only if is a logical operator. You will graduate is a simple statement. You meet all university requirements, simple statement. You put them together, it's a compound statement. How about run and jump? That was a trick question because run and jump is not a statement. Remember, a statement is a sentence that is either true or false. Run and jump is neither true nor false. It's a command. Okay, so now that we know how to translate simple statements into our logical language, and we know the difference between a simple statement and a compound statement, I'll teach you how to translate logical operators into our symbolic language. So, as I said, logical operators, they're special symbols that are used to translate logical connectives from ordinary English into propositional logic. So a logical connective would be something like not, and, or, if then, and if and only if. Logical operators would be tilde, dot, wedge, horseshoe, by-conditional. And actually, you can refer to English as operators or connectives, and you can refer to the the symbols in propositional logic as connectives or operators. It's interchangeable. But in English, there are things such as not, and, or, etc. In our logical language, it's such things as tilde, dot, wedge, horseshoe, by-conditional. Okay, so our first logical operator that we'll look at is negation. A negation is a statement with a tilde in front of it. The tilde is a logical operator in our language that is used to translate phrases like not, and it is not the case that. These things deny the statement that follows them. Okay, these things deny the statement that follows them. So how do you translate those? So first, take a statement in English that has a negation. Obama is not president. First, you represent the statement that is negated with a statement letter. So Obama is not president. Let's represent that with O. Then you represent the negating phrase with the tilde and place the tilde directly in front of the statement. So tilde, O. Here are some other examples. Today is Monday. You translate that as M. if you'd like, or T if you'd like, or P if you'd like. The way you would translate today is not Monday is you take today is Monday, the simple statement, and you translate that as M. And then you take the not, the logical connective, you translate that as tilde, and you squish them together. You put the not first, and then the statement letter second. Not M. That's how you represent today's not Monday in our in propositional logic. So let's look at the next example. Gold is selling at $1,000 an ounce. That's a simple statement. We'll represent that with G. It is not the case that gold is selling at $1,000 an ounce. So again, we represent gold is selling at $1,000 an ounce with G, and it is not the case that, as tilde, you put the tilde first and the G second. So that's how you translate negation, a negated statement, into propositional logic. Conjunction. How do you translate a conjunction into propositional logic? A conjunction is a compound statement with two distinct statements. We call them conjuncts, connected by the dot symbol. The dot is a logical connective. So it translates things like and, but, still, moreover, while, however, also, moreover, etc. The way you translate it is, again, with your simple statements, you just represent those with a capital letter in English. Honesty is the best policy. Lying is for scoundrels. Let's say honesty is the best policy. We translate as H. Lying is for scoundrels. We translate as L. The word and, it's a conjunction. We're going to translate it as the dot. So a result is H dot L. H dot L. So with the second example, we see that the only difference is that and is switched out for moreover. And if you look at the list above, moreover is one of our phrases that we translate into propositional logic with the dot symbol. So, honesty is the best policy. Moreover, lying is for scoundrels, translates the same way, H dot L. And Frank and Ernest teach music. Well, that's a conjunction, a compound statement, a conjunction of Frank teaches music and Ernest teaches music. So we represent Frank teaches music with F and Ernest teaches music with E. And we put it together with the dot. So then the way that you would translate Frank and Ernest teach music is F with the F dot E. There's also disjunction. Disjunction is a compound statement with two distinct statements, or disjuncts, connected by the wedge symbol. The wedge is a logical connective. So, the wedge translates English words such as or, unless, otherwise, and either or. Here are some examples. Paris is the city of lights, or Big Ben is in London. You have the simple statement, Paris is the city of lights. We could represent that with P. The simple statement, Big Ben is in London. We could represent that with B. And the phrase or, we could represent that with the wedge. P, wedge, B. That's how you translate that statement. She is either tall or short. Either or, we take it as one logical connective, and you notice that she is either tall or short is a compound statement with two simple statements, as you see in the parentheses. She is tall or she is short. Okay, so the way we translate it here is P wedge S. I'm taking she is tall to be represented by P, she is short to be represented by S, and I'm putting the wedge in the middle. Unless it rains today, we will go swimming. It rains today is a simple statement. We will go swimming is a simple statement. And unless, if you look above, is translated with the wedge. So I'm going to translate "it rains today" with R, use R to translate it. "We will go swimming," I will use S to translate it, and I'll put the wedge in the middle. The way we translate it into our propositional language is R, wedge, S. Now, conditional statements. These are two distinct statements joined by the horseshoe symbol. The horseshoe is a logical connective. In English, they are if-then statements. So we use the horseshoe to translate if-then statements. So if you clean, then you can go to the movies. So imagine, a parent is saying this to their child: if you clean, or if you clean your room, then you can go to the movies. Notice that "you clean" is a simple statement. "You can go to the movies" is a simple statement. "If then" is a logical connective. We represent "you clean" with C, "you can go to the movies" with M, and then we'll put the logical connective horseshoe in the middle. Now, it's really important. Listen, this is really important when you're translating if-then statements. You put the phrase that comes after the "if" before the horseshoe, and the phrase that comes after the "then" after the horseshoe. You put the phrase that comes before the "if," you put the phrase that comes after the "if" before the horseshoe, and the phrase that comes after the "then" after the horseshoe. I'm sorry. Let me say that one more time. You put the phrase that comes after the "if" before the horseshoe, and you put the phrase that comes after the "then" after the horseshoe. So we can see that with the next example. "You can go to the movies if you clean." In this one, the "then" is implied. Okay, so we're going to translate it the same way. We're going to put "you clean" before the horseshoe, and we're going to put "you can go to the movies" after the horseshoe. Why? Because the phrase that follows the "if" goes before the horseshoe. The phrase that follows the "then," in this case it's implied, goes after the horseshoe. Okay, then there are two terms for the different parts of the if-then statement. The phrase that comes after the "if" we call the antecedent. The phrase that comes after the "then" we call the consequent. So, when you translate, you put antecedent, horseshoe, consequent. You'll need to know those terms in this class. Here are other ways of putting the conditional. Every time P, then Q. P is the antecedent, Q is the consequent. Each time P, then Q. Anytime P, then Q. Given that P, Q, etc. So in each case, the P is the antecedent, the Q is the consequent. You should learn some of those ways of translating the if-then. You should learn some of those other ways of putting the conditional into English. When you translate them into propositional logic, it's going to be the same way every time. It goes antecedent, horseshoe, consequent. So every time P, then Q would be translated as P, horseshoe, Q. Okay. So with conditional statements, sometimes they're put as only if rather than if then. And how do you distinguish if from only if? Well, the thing is that if typically precedes the antecedent of a conditional statement, only if precedes the consequent of a conditional statement. Okay, so when you translate, you always put you always treat the if. When you translate, you always treat the phrase that follows the word if as the antecedent. Unless you see the phrase only if. When you see the phrase only if, the thing that follows the if is the consequent. So let me say that all again. When you're translating if-then statements, you treat the phrase that follows the if as the antecedent, unless you're dealing with the phrase only if, in which case you treat the thing following the if as the consequent. So, here are some examples. If the light is on, then the neighbors are home. The phrase that follows if is the light is on. We treat that as the antecedent, so we put it before the horseshoe. And we'll represent the light is on with L, and we'll put it before the horseshoe. The neighbors are home. We'll represent the neighbors are home with N, and we'll put it after the horseshoe. Why? Because it's the consequent. The lights are on is the antecedent. The neighbors are home is the consequent. But if you have the light is on only if the neighbors are home, the phrase that follows the only if we treat as the consequent. The phrase that precedes the only if we treat as the antecedent. And there's a logical reason for this. But I won't go into it just yet. If the neighbors are home, then the light is on. So neighbors are home is the antecedent, so we put it before the horseshoe, represented by N. Light is on is the consequent, we put it after the horseshoe, represented by L. Only if the light is on will the neighbors be home. The light is on in this case is the consequent, so we represent it with L and put it after the horseshoe. The neighbors will be home is the antecedent. We represent it by N and put it before the horseshoe. Okay, finally, we have biconditional statements. These are two distinct statements joined by the triple bar. The triple bar is a logical connective. It's used to translate biconditional statements, which are two statements joined by a phrase like if and only if. If and only if, it occurs in everyday language, and it's just a combination of if then and only if. So you get your ice cream if and only if you eat your spinach. You would translate that as I biconditional S. You get your ice cream, we're going to represent that with I. You eat your spinach, we're going to represent that with S. And then if and only if we'll represent by the horseshoe. Now, when it comes to the biconditional, it doesn't matter which order you put the statements in. We put you get ice cream to the left of the biconditional. We put you eat your spinach to the right of the biconditional, but it could have gone the other way around. The order matters in the if-then statements, not in biconditional statements. All right. Here's a little bit more on biconditional statements. They can be broken down into a conjunction of two conditionals. And these conditional statements are mirror images of each other. So the left side, so let me say what I mean by a conjunction of two conditionals. So look at the example at the bottom. If you eat your spinach, then you get ice cream. That's one if-then statement. You get ice cream only if you eat your spinach. That's another if-then statement. And it's joined by and. And this is the way we translate it. S horseshoe I and I horseshoe S. S horseshoe I dot I horseshoe S. That's equivalent to a biconditional. A biconditional is just taking those two if-then statements and squishing them together in one single biconditional statement. The way you would translate that would be S biconditional I. Okay, so when I say they're mirror images of each other, what I mean is that the left side serves as so if you have S horseshoe I, the left side S serves as the antecedent in one of the conditionals and as the consequent in the other conditional. The right side, so if we have S horseshoe I, S biconditional I, the right side I serves as the antecedent in the conditional in which the left side serves as the consequent, and as the consequent in the conditional in which the left side serves as the antecedent. That's confusing, I know, but think about it. Listen to this portion of the lecture a couple of times, and I think you'll get it. Okay, those are all the logical operators. Here's a neat little table to show you the operators, their names, the compound type, and what they're used to translate. So we have the tilde. It's called the tilde. It's a negation. It's used to translate the words not, and it is not the case that. It's used to translate other things as well. These are just examples. We have the dot. It's named the dot. It's a conjunction. And it's used to translate the words and, moreover, but, etc. The wedge. It's called the wedge. It's a disjunction. It's used to translate or, unless, etc. The horseshoe symbol. It's called the horseshoe. The compound type is conditional. That should say conditional. And it's used to translate if, then, and only if. There are other phrases that it's used to translate as well. Then we have the operator triple bar. We call it the triple bar. The compound type is biconditional, and it's used to translate if and only if. Okay, so let's practice now. How do you translate the following statement? I am not happy. Let H equal I am happy. You translate that by B. B. You wouldn't translate it by A. A just says I am happy. Where H equals I am happy, that translates I am happy. B, you've got the tilde, and then you've got the H. That translates I am not happy. Tilde is used to translate not. The H is used to translate I am happy. Dot H, that's not it either. The dot is the conjunction, not the negation. And then as for D, we have tilde lowercase h. Remember that statement letters are supposed to be translated. Statement letters are supposed to be uppercase. You only translate simple statements with uppercase letters. And then it's not E either because the tilde comes after the H. The tilde is supposed to come before the H, right? And we'll learn a little bit more about how to properly construct statements in propositional logic. We'll learn that a little bit later. But for now, just know that you would translate it as option B. How do you translate the following statement? John and I are not happy. Let J equals John is happy. Let H equal I am happy. You would translate that with C. John is not happy and I am not happy. Because the statement John and I are not happy, it's saying that for both of you, you are not happy. John is not happy and I am not happy. So C is the proper way to translate it. A is not the proper way to translate it because all that's saying is John is happy and I am happy. There is no tilde negating the statements. B is not the proper translation. That says John is not happy and I am happy. But I am not happy. The statement itself says that I am not happy, so that would be improper. D is not appropriate. That just says John is not happy. That's leaving out I am not happy. And E is not appropriate. That says I am happy and John is happy. So the only option is John is not happy and I am not happy, which is C. You have the tilde negating the J, so that means John is not happy. You have the tilde negating the H, that means I am not happy. And you have the dot putting them together, that means and. John is not happy and I am not happy. Or you could say it, John and I are not happy. Okay, how do you translate the following statement? Either we reduce global emissions or global warming will get worse. Let E equal we reduce global emissions. Let G equal global warming will get worse. So technically you want to pick C. That says E wedge G. We reduce global emissions or global warming will get worse. G wedge E in option A actually is correct as well. Logically, it doesn't matter whether you put the G on the left or the right, whether you put the E on the left or the right. So logically, it doesn't matter. If you put G wedge E on the test to translate this statement, either we reduce global emissions or global warming will get worse, you would get full credit because logically it's okay. But it's best if you mirror or reflect the English as best as you can, which puts we reduce global emissions first and global warming will get worse second. B is not appropriate because it uses the dot. The dot is used to translate and. D is not appropriate because it uses the dot. The dot is used to translate and. Plus, it has the tilde, which means not the case that we reduce global emissions. And E is not the right answer. That's just the word cat. Okay, how do you translate the following statement? If the IRS processed my return, I should get my refund this week. Let I equal the IRS process my return. Let R equal I should get my refund this week. All right, A is the answer. When you look at this sentence, if the IRS processed my return, I should get my refund this week, you know that the antecedent comes directly after the if. So the IRS processed my return is the antecedent. And when you translate that, you know that the antecedent comes before the horseshoe. So the antecedent follows the term if, and the antecedent goes before the horseshoe. So that's why we put the word I, which represents the IRS processed my return, before the horseshoe. And whatever follows the then, in this case the then is implied, whatever follows the then is the consequent. So I should get my refund this week follows the implied then. And that the consequent always goes after the horseshoe. B is not correct because it has the wedge. The wedge is used to translate or statements. C is not correct because it switches the antecedent and the consequent. It puts the consequent before the horseshoe and the antecedent after the horseshoe, but that's not right. D is not the correct answer because it uses the by-conditional. It uses the triple bar. What D says, if you translated it back into English, is if the IRS processed my return, I should get my refund this week, and I should get my refund this week if the IRS processed my return. Excuse me, let me say that again. I got it a little inaccurate. So what the by-conditional says, if you translate it back into English, is this. If the IRS processed my return, I should get my refund this week. And if I should get my refund this week, then the IRS processed my return. That's what it should say. And then E is not correct because it's a picture of a pie. I mean, come on. All right. How do you translate the following statement? You will graduate if and only if you meet all university requirements. Let Y equal you will graduate. Let U equal you meet all university requirements. Okay, so C or D. If you want to reflect the English as accurately as you can, then you should put D. Because it says Y equals you will graduate. You put the that comes first in the sentence. You put the Y before the horseshoe. U equals you meet all university requirements. That comes after the if and only if in the sentence. You put it after the triple bar. Okay, but you could switch it around and logically it doesn't matter. So C or D works. You'll get full credit on the test if that's how you translate an if and only if statement. A and B are incorrect because they're only conditionals. A and B are incorrect because they're only conditionals. If you translated A back into the English, now let's see if I can get this right. It would be, if you will graduate, then you meet all university requirements. And B would be, if you meet all university requirements, you will graduate. That's why A and B don't accurately translate the English statement, because the English statement has if and only if, and it doesn't just have if then. Now let me go back to the previous slide. The D option, you could have translated that as, the IRS processed my return if and only if I should get my refund this week. All right. So the way I said it before was two conditionals joined by the and that's technically correct. But you could also put it in terms of an if and only if. Okay, so one word of caution, given all of this. The caution is that the symbolic translations, the translations into propositional logic, they're not synonymous with the original English expression. So wedge does not mean or. The dot does not mean and. We're going to learn what the wedge means. We're going to learn what the dot means in a further lecture, in a future lecture. So don't confuse the wedge with the meaning of or. Don't confuse the dot with the meaning of and. Just know that you translate the wedge, translate the or with the wedge and translate the and with the dot. It's like when like if you didn't know Chinese, but you learned that happy is translated into Chinese by a certain symbol. Well, we haven't given you the meaning of the symbol. We've just told you how to translate the word happy in English into the Chinese symbol. Okay? So here, I haven't told you what wedge means. I haven't told you what dot means. I've just told you how to translate words from logical connectives from English into propositional logic. So the thing is, the reason we do this is because English expressions are often ambiguous, so you don't want to just say wedge equals or. So we're going to specify the meaning of our logical operators in such a way so that they're completely unambiguous. That's all I have for you today. That was a long one. I hope that you understood it, and watch it again if you didn't, or ask me questions via email.